Oh. Now it's green. It works like a charm. No? Worked out of the box. This is not a Windows platform. I don't have a microphone.
This is the mic is for recording, so you
Okay.
can
Stay close.
yeah.
Okay, that's good. Thank you. Okay. Hello, good afternoon. I'm glad so many of you found this room. My name is Tom de Seen, and I'm a Red Hatter working on .NET Core. In this talk, we'll explore what .NET Core is, and we'll zoom into the open source and cross-platform aspects. At the end of the presentation, I'll be joined by Jeff, who's a program manager on the ASP.NET team. So let me begin by explaining what .NET Core is. So most of you will know the .NET Framework. The .NET Framework is the development platform Microsoft first released about 15 years ago. It's the de facto programming platform for building Windows GUI applications and Windows web applications. Shortly after Microsoft first released the .NET Framework, an open source and cross-platform implementation came about. Of course, I'm talking about Mono. And Mono has allowed us to develop and run .NET applications on Linux for many years. The Mono project is led by Xamarin, and Xamarin was acquired by Microsoft about a year ago, and Xamarin provides a .NET platform for building mobile applications. .NET Core is a new .NET platform intended to build cross-platform services. Let me zoom into that. So .NET Core is cross-platform. It runs on Windows, Linux, and Mac. It's completely open source. This includes the runtime, the class library, compiler, and all the tooling. So the source code is available, and it's also open for contribution. It's very fast. Some of you may have attended Jeff's talk this morning, where he mentioned ASP.NET Core is capable of handling millions of requests per second. Such performance is only achieved by making it a clear goal and by optimizing throughout the entire stack, which of course includes the runtime, the class library, and also the compiler. And every optimization made there is beneficial for all apps running on .NET Core. .NET Core is also ideal for microservice development because it's fast and also because you can build really small microservices. This is possible because applications can trim their dependencies. If you attend Nemanya's talk later, you will see how to build a really minimal MVC application. And also the runtime itself only weighs about 50 megabytes, so deploying .NET Core-based microservices comes at really low overhead. The main programming languages of the .NET platform are C#, F#, and VB. C# is a modern general-purpose programming language. It's the most popular programming language of the .NET platform. Most open source projects you see out there, including .NET Core, are written in C#. F# is a functional programming language, and VB is an easy, approachable, general-purpose programming language. Because we have multiple platforms, we need a way of writing code and target all of them. This is where Net Standard comes in. Net Standard is an API definition, and libraries will target that API. And then the platforms implement the API, which makes the library run on the different platforms. Making this a little more concrete, the columns of this table show the different versions of Net Standard. and each successive version adds more APIs. So suppose we write a library which is targeting .NET Standard 1.3. That library would run on .NET Core 1.0, and it would run on the .NET Framework 4.6. If in our library we would like to use newer APIs available in .NET Standard 1.4, 1.5, or 1.6, our library would no longer work on the .NET Framework. The next version of .NET Standard is .NET Standard 2.0, and it will be implemented by .NET Core, which will be shipped in spring this year. And it will bring a much larger common API surface between .NET Core and the .NET platform. What also will be possible is that .NET Standard libraries will be able to use other libraries which are not yet .NET Standard aware, but which would be .NET Standard compliant. All in all, this means that porting applications from the .NET Framework to .NET Core will become much easier, and it will also be possible to share much more code that runs on all of the platforms. So this is the API surface of .NET Standard 2.0. It contains really a lot of useful stuff. And what's interesting to know is that some of these things were already in .NET Core, but not yet in .NET Standard. For example, the thread class was available in .NET Core, but because it wasn't in .NET Standard, it was not possible to write a library that used the thread class which worked across the different platforms. This will now be possible thanks to .NET Standard 2. As I mentioned, .NET Core is open source, so the source code lives on GitHub. It's MIT licensed, and it's copyright of the .NET Foundation. The .NET Foundation is a non-profit organization, and it's here to help support the .NET open source ecosystem. The technical steering group includes Microsoft, but other companies are also part of it, like Red Hat, Samsung, and Google. The binaries built by Microsoft for the Linux platforms are also MIT licensed. These pictures come from a blog post by Matt Warren, where he looks at the .NET Core open source journey for the past 2 years. So each of these graphs represent activity. Each bar is 1 month of activity, and they start in November 2014 and go till October 2016. On the left, you see the runtime, and on the right, you see the class library. The top row is the number of issues created, and the bottom part is the number of pull requests. You see a clear increase for all of these graphs. What's also indicated per bar is the darker part. This is community contributions, and the lighter part, this is Microsoft contribution. So you see the community is also actively creating issues and also pull requests. And when we look at the absolute numbers of these graphs, they are quite high. For example, for the class library there, in October 2016, there were 500 pull requests, which is a pretty nice number. And for the runtime, there were 250 pull requests. So .NET Core is cross-platform. For .NET Core 1.1, there's binaries provided by Microsoft for a number of popular Linux distributions, and for Mac and Windows as well. At Red Hat, we also built .NET Core, and we provide it for RHEL and for OpenShift. For RHEL, it's available as part of the no-cost developer subscription, and we closely follow the upstream releases. This means when Microsoft releases their upstream version of .NET Core, only a few days later, it's already available on RHEL as well. So as I said, the packages are built by Red Hat, and they're provided as a software collection, so you can install them on your system, and it won't impact the rest of your system, and you just activate them when you need them. The commands show you how to enable the subscription, install .NET Core, and then enable the software collection. We also provide a source to image builder for OpenShift. This means you can hand your source code in a Git repository to OpenShift, and OpenShift will build your .NET code, and it will then deploy it. Doing this is as easy as this one-liner command there at the bottom, where you see you specify the runtime you're targeting. So in this case, .NET Core 1.1. You give your Git repository with its source code, and then you specify where the startup project is inside this Git repository. And after issuing this command, OpenShift will pull your code compile it, and then deploy it in a container. The cross-platform story is even getting more interesting for .NET Core 2. Microsoft will provide a Linux x64 build, and this will allow us to develop applications and publish them standalone, and they will run on, let's say, all the popular Linux distros out there, without there being a .NET installer or a .NET runtime specifically for that distribution. So this is a pretty nice feature. And then also very interesting for distro maintainers, building from the source code will become a lot easier. So if you're building .NET Core, thanks to changes made to the repository layout and the build artifacts, building from source will become easier. Now it's demo time. So Jeff will join me, and he'll first demonstrate a web application running in Visual Studio on Windows, and then he'll publish that standalone so I can run it on my Fedora machine.
Got to get some display. You'd like to see what I'm actually doing on my laptop, wouldn't you? That'd be nice.
Let me try to.
Fantastic. Very cool. All right. So here I am on Windows. I know Windows, right? I mean, but I have Visual Studio 2015. This is the Community Edition. It's a free version that's available for hobbyists and for small companies that are in startup mode. And what I'm going to do is I'm going to open the web application that Tom gave me. I have it sitting right here, and this is the source code that he started with. So I'm going to open that here in Visual Studio, and in just a second it's going to come back, do a little bit of conversion, and I will have my project open. So now it's going through, and you can see on the bottom it's installing packages. Okay? We have packages that we use, just like you guys have on Red Hat, that have all the different components, little modules as part of the .NET framework, .NET Core framework. And you can also see over here on the right, it's restoring other dependencies. Well, that's because inside of Visual Studio, we also restore those client-side dependencies for Bower and NPM automatically for you as you make changes to your Bower JSON and package JSON files. So it's going to go and finish bringing back all the necessary things that I need to make my client-side web application work. Now, while that's finishing up here, I can actually tell Visual Studio to build my application. I just went through and used the hotkey for build and then build application here. And you didn't even see it because it's actually still waiting. But what it'll do is it'll dump here into my output window the results of what happens during my build process. And I'm fighting the network again. Let's see. No, we're good. Of course, NPM is going to take a while to install. I have all kinds of other windows here inside of Visual Studio that I can use to see what's going on. There we go. We can see it's starting to bring some of these things back. That's finishing off. I can actually look and see what's going on with my package manager, and I can watch what those things are doing over here. This is for the .NET packages, my NuGet packages. So I'm going to go over here to my output, and not that one. There it is. So you can see that it finished building. The actual build of my .NET code took only 1.9 seconds. Pretty fast. A lot faster than it took to download all that JavaScript. But here locally on my Windows machine, I can start my application and use the native Windows server, IIS Express. This is a developer-focused web server that I can attach to and debug with without needing administrator privileges on my machine. So I click play, and it'll compile and show me my application, in this case running in Edge, because I'm running Windows 10. Everybody okay with Edge? Chrome? Firefox? Okay. One person likes Firefox. Nobody else likes Chrome. All right. So I have this simple templated website put together that Tom sent me, and I can come through and I can make some changes and whatnot. But really, what I want to do here is I want to maybe do some debugging, and that's easy for me to do with Visual Studio. And I have these features also in Visual Studio Code. I can go into my controllers where I have some C# code written, and I can actually look at all the different code here. And if I want to pause the action, I can put a breakpoint, let's say right here, where it's going to return the view, right? And in the MVC framework, we have a controller, we have a view, and we have a model. Well, in this case, there's no model. We just have a view that's some templated C# and HTML that we call Razor. And we're going to return the view information for this index action inside of my home controller. So that view actually lives here under my views folder, under home, and it's called index. Makes sense. It's designed by convention. The name of my controller, the name of my action, is the name of my Razor file sitting out here. And you can see it looks just like standard HTML, and it's got some C# that's mixed in with it. Where is it? Up here at the top you can see surrounded by this @ symbol. Okay? This is C# code that's being executed, and then it'll be dropped in a little bit later anywhere that I use that @ sign, a context switch, and I flip from HTML to C#. And as soon as that C# code is done executing, it'll actually change context back to HTML again. I think you can see that better in the layout of this template. There you go. So here's some HTML, the title tag, and then some C#. It's in this gray highlight. It's kind of hard to see on the projector. And then it changes back to HTML context. And that's a feature of our Razor templating engine that we use. But I'm going to put this breakpoint in here because I want to be able to inspect what's going on inside of my web browser, my web server, because my breakpoints occur server side. So this will start up, and Visual Studio attaches and shows me, here's where we're stopped at. I have some locals that I can look at and actually watch the state of the interaction with my web server. So I can look at the URL that was requested, the information about the HTTP context that was passed to my session, and I can inspect and see exactly what's going on right here inside of Visual Studio. There's other tools that we have built into other versions of Visual Studio that will allow me to profile and take a look at everything that's loaded into memory, or where the processor is actually doing its work, so that I can find those hotspots and tune my application easily. So,
even on Linux?
So this is on Visual Studio that runs on Windows. You can attach to a Linux machine that's running and debug and profile over there. So, but you need to be running with the full version of the IDE. Mm-hmm. So we can also run this version of the tool and attach to a Docker container that's running a Linux image and be able to debug and profile what's going on inside of that. Very cool options that we have available. So that's nice that I can come through and I can take a look at this. The last thing that I wanted to show you is inside of Visual Studio, and this is the same for all of our Visual Studio versions, including code, we have this great feature that we call IntelliSense. And it's not like that type ahead stuff that you can see in Sublime, where it sees other things that were completed in your code and it tries to figure out something that matches. We actually, on the fly, compile your code and then inspect and give you features that are available for you to do with your code. So if I do things in here, like if I have a var I equals 0, so I is clearly an integer, and I say I dot, here, let me zoom in there. You can see I get integer-like things that I can do with this, all right? But if I change I to a string, and I look at what's here, now I have string things that I can do with this variable. Okay? So it's clearly actually compiling the code and giving me appropriate options for interacting with that variable. So very cool features, and like I said, you do get those in Visual Studio Code that runs on all platforms. But you know what, this application looks like it's running pretty well. I want to compile it and make it available so that Tom can run it back on his Red Hat machine. So what I can do is I can go into that folder, and I'm going to navigate down to the actual application. Let me pump up the font size here just a little bit. So now everything with the .NET framework runs with the .NET Core and SDK runs on the command line. It runs command line first, and then we build Visual Studio on top of it so that everybody gets the same feature set regardless of what tool they're using. So you run the command line by just calling .NET and then a series of commands that you pass in. So I'll call .NET build. It knows that it was modified, compiles, and it's done. And now I'm going to publish it so that it's available for use on Fedora. In order for me to do that, I'm going to come through here and make sure that all of my appropriate content is available and deployed. So everything that would be in the .NET Core framework that's installed locally on my Windows machine needs to be bundled up and shipped with my application so that Tom can use it. So what I do is I'm going to change this reference to the .NET Core app. Instead of it being a platform is something that's installed locally and shared across many projects. I'm going to remove that so that it's actually packaged and brought with my application. And then I'm going to scroll down to the bottom here, and I'm going to add another segment to specify the runtimes that I'm going to support. So what I do, and see it's even helping me here with some type ahead, runtimes. And I'm going to specify two runtimes. I'm going to specify Win7 x64 because my machine is a Windows 7 variant here, so I need to still be able to compile for my machine. And then yours is Fedora 24? Yes. So let's reference Fedora 24, and that's x64. So I'll say x64. And now you can see over here, I made the change, and Visual Studio is restoring the appropriate packages to support Fedora 24. I can take a look, and I can see exactly what it's doing. What's even better about these little console windows, you can scroll up and see exactly the command that it executed. So it set the path, and then here it said .NET restore, and it specified someplace to write some output to. So it's all done. It restored everything. So I will .NET build one more time. Right? There it goes. Good. Everything built. Now I can publish. Right? Publish is what's going to do that gathering of all my references and make it available in one folder. So I say, let's move this up to the top. .NET publish. And then I'm going to specify a runtime, because I need to actually say that I'm not publishing for this machine and this runtime. I'm publishing for a different one. And I can pass in a collection of runtimes if I wanted, or specify one that I don't necessarily support with this machine, like Fedora. I could also specify things like Mac OS if I wanted to. But in this case, let's specify Fedora, spell it right, Jeff, Fedora 24 x64. So it's going to publish that and carry along the appropriate runtime for me. And now that it's done building, here it goes. So it's gone through, it's marked everything up, and now it's sitting down here in this folder. So let's just show you what that folder looks like. It's under bin, debug, .NET Core app, and take a look. I've actually got a Win7 one sitting here, but if I look in Fedora 24 x64, these are the things to install if I had a .NET runtime on my machine, but I've got everything necessary right here with all my views, my static files that live in the www root folder, and all my DLLs that I need to ship. So this is the part where I do the Julia Child fake out and look, I'm already done baking the cake. I've actually already packaged this up and I've sent a zip over to Tom so he can show you what happens after he receives this published folder.
Okay, thanks. So as Jeff was riding the train to Brno, he sent me the zip file that he created just as he demonstrated before. So I have it here, the Fedora 24 zip, and I will just unzip it. And everything is in there. So by removing the type platform from the project JSON, Jeff ensured this was a standalone .NET application, which means I don't need .NET to actually run this package. Of course, since I'm a .NET developer, I have it on my system because it's on my pod variable. And let me just change my pod variable to convince you. Voila, it's no longer on my pod variable. And this folder, because Jeff created it, the permissions are not 100% okay because Windows doesn't know the execute permission. So I need to make one change, which is add the execute permission to the web application binary, and now it is just running. So the application developed and published standalone can just run on your Fedora machine without there being any requirement for that .NET being available there, which is quite nice. So let me open up this link to show you. It is working quite well here. This is a very nice feature. And as I said during my presentation, .NET Core 2 will bring a Linux x64 RID. So where Jeff just showed us using Fedora 24, at that place we will be able to use Linux x64, and that will enable the standalone application to run on all major Linux distros. So Jeff was using Visual Studio on Windows. I will show you Visual Studio Code here running on my, let me open up a new terminal just to get my regular path. And there I will show you Visual Studio Code. Visual Studio Code is a free open source IDE. It supports quite a number of programming languages, including C#. You enable that by installing the C# extension. Just like in Visual Studio, Visual Studio Code has IntelliSense. So this is also powered by OmniSharp, and OmniSharp is also open source, and it uses Roslyn, which is the .NET compiler platform under the hood. So if I use the app variable here, which is an iApplication builder, it shows me all the methods which are applicable for that type. If I pick one of the methods, I can see the different overloads which are available. So IntelliSense powered actually by the same tooling which is powering also Visual Studio on Windows. I can also go and debug that app. I put a breakpoint here, so I can launch a debugger here from Visual Studio Code, and you will see everything you'd expect a debugger to have available. So once we hit that breakpoint, I'll see a list of variables show up here. I can zoom into that, look at what is here. For example, the env content root path for this demo, etc. Here you can see the call stack, and you can just have a very nice debugging experience here, also while developing using Visual Studio Code on your Linux machine. The last thing I want to show you is also a cross-platform feature, let's say. is publishing this application into OpenShift. So OpenShift is a container platform, and Red Hat is contributing a lot into OpenShift. And as I said during my talk, we have a source-to-image builder, and the source-to-image builder is capable of taking .NET code and just build it and deploy it. And that's what we'll do here. So if I look, my code here is on GitHub, and I can just use the OC, which is the OpenShift client tools. And I create a new project here for OpenShift. So my project shows up nicely here in the GUI. And next thing I'm going to do is OC new app. I specify my runtime, which is .NET 1.1. Now I give it a URL to my source code repository. I tell it where my startup project lives inside this repository, and I need to set one env var, and this is actually mapping the port the ASP.NET Core website will be using to the port exposed by the container running in OpenShift. So after I issue this command, you see that a build has started in OpenShift. I can just click here, and we're waiting for the build to start. And this build log, which will show up in a couple of seconds. You can also just fetch that on the console using the command that the OpenShift client tools just gave us there. So now it's pulling this this builder image, and then it's pulling in my source code from GitHub. And the first thing it will do is what you also saw in Visual Studio, is it will restore the .NET dependencies specified in the project JSON file. So there it goes. It will fetch the dependencies.
Does it use a special builder image and then run on a different image?
This is the builder image, which comes already with OpenShift, and we're making some improvements to that as we learn ourselves how .NET Core applications are built typically. So, for example, the ASP.NET Core URLs, which I had to set there in the next version of the builder image, that will be included. So you'll no longer have to specify that variable. Jeff also showed some tools like Bower and Gulp. You will be able to enable those. So if you want to use those for your front-end website, you will be able to say, I'm using the Gulp task runner. Please make sure it's available when I build it. So like that, OpenShift will also be able to build your front-end using the JavaScript tools you like most. So it restored the dependencies, and then it started building our app. And as a last step, it will take the app and it will publish it as a container into OpenShift. And this will be our runtime container. So this will be the container which is launching the .NET application. So at the end of the log, it will push like 4 layers of a Docker image. And then it will take that image and deploy it. I'm actually using an OpenShift staging server, so sometimes I see some error message which is not on the production server, but I ignore it.
So if I understand well, it doesn't run Bower and Gulp at the moment?
No, because
Just C#.
Yeah, this is a plain C#, and I ran actually for this project in advance the Bower and the Gulp tools, because it is not yet available in the source-to-image builder, which is now in OpenShift, but when we upgrade the builder, you will be able to specify. So while it's pushing these images, I can show you this repo. So the source code for the image builder is also online on GitHub, and if we have a look in the README, you will be able to specify with an env for your build deployment the tools you want. So if you would set this variable to gulp Bauer, it will do an npm install, and you will be able to use those, for example, as part of your publish step. Let's see where we are. So it's pushing the layers still. It's a good time to drink a cup of coffee. One thing we also want to do is make the runtime image a bit smaller, and this would also make this step a bit faster. So,
one more question. On Windows, we saw you run the application in IIS Express. What is the web server running here?
So I think in Windows probably it was using IIS Express as the front-end web server, and then Castrol after it. So Castrol is the open source .NET Core HTTP web server, and it is using Castrol here as well. And it's a very high-performant web server. It is capable of handling millions of requests per second. And Jeff mentioned in his talk also the Tech Empower benchmark, where you can see how it is performing against some other well-known web frameworks and web servers. So we are using to run the .NET Core application exactly the same web server as Jeff was using in his demo.
When you compare performance between Windows and Linux?
Actually, comparing performance here, there is an ASP.NET benchmark repository, I think, but as far as when I last looked at it, it hadn't been updated for a while, but there are different scenarios here which you need to take into account. So if you look at like the Tech Empower benchmark, it is using Castrol and nothing is in front of it. For example, Jeff was using their Castrol with IIS in front of it. Performance will of course be a lot lower there. If you put Nginx in front of that, it's a very fast web server, but if you put something in front of it, which you will most likely do in a production scenario, performance will be less, and it depends on what you put in front of it. If you're running it in a container, then of course something will be in front of it again. So it depends on your deployment, where Castrol is running, and who is handling the requests.
Yeah, but does mean that it's environmental to have, let's say, a horizontal comparison. How does it look? Because I don't see a business for Microsoft to follow this step actually. So it's a big question.
Well, it's running the same web server, so the interest in having a high-performance web server is really there, the same. And Microsoft wants to make this a great web server on Linux as well. Do you want to add something, Jeff?
So the question was, what's the interest in Microsoft in making a high-performance web server that works the same on both Linux and Windows? And we want to maintain one source code base. We want to make sure everybody gets the same features at the same time, and that we don't rely on something that's deep and embedded in Windows that not all the other operating systems have. So that helps us also make sure that it will work great when we deploy to the cloud, whether it's Azure or OpenShift or the bookstore at Amazon, right? We want to make sure that it works great on everybody's cloud. So the Kestrel web server is really designed to be rebuilt from the ground up and very highly compatible. We're seeing numbers in our most recent tests that looks like Kestrel is about 5% faster on Windows than on Linux. It's still millions of requests per second, so you're in pretty good shape. When you put that behind an Apache or Nginx server, you're going to see performance drop off a little bit, but it's a trade-off for more security, better protection.
So, and I think the ASP.NET benchmark repository is really the place where you need to look to see what the numbers are, and also the different front ends who are taking your requests and handing them over to Castrol there. So probably there will be an update in the near future of those benchmarks. Yep. So in the meanwhile, our runtime image was pushed into OpenShift, and here it is running our web application. So this service is now running internally in OpenShift and could, for example, be an internal web API project. We want to expose it. So I'm going to run the expose command here, and now the website we just built in OpenShift and deployed is available to everyone on the public internet, and there it is. So quite nice. Only handing it a URL and building and deploying in OpenShift. So that was it for the demo. We already had some interesting questions. Are there other questions? No? Thank you for attending the talk. Thank you, Jeff, for helping me with the demo. That's it. Cool. You're welcome. Thanks. I was
Right, it's that method that'll go get the models. Yep. And then the other parts of the we call those route parameters. Right, those things will be parsed out, and if there's if there's input parameters to that method, they line up, and if you can go scramble around first before a page, by internet. What you get is a 3-8-hour course on Microsoft Virtual Academy. So you can go out online. If you go to, I think it's Microsoft Virtual Academy. There's 3-8-hour courses. I'm in the middle of 8 hours talking about that phase. Intermediate, a lot of stuff where recently did generic version of it, showing how we got some local things on stuff that we the focus at Unique days is really for all the things that you're doing, if you're on Mac, all right, and your name? Nice to meet you. Good luck. Feel free to tell me on Twitter if you have any questions.
Vždycky jako